Hello, and welcome to the Vector virtual session deploying continuous quality for software and system projects using Squore. My name is Flavien Huynh. I've been working in the Vector PCT team for over 2 years. In the next 20 minutes, I will present you continuous quality, its benefits, and how it can be deployed with Squore. I will also make a short demo of an actual continuous integration using Squore to provide continuous rating, checking, and reporting. Deploying continuous quality for software and system projects with Squore. We could have called that quality as a continuous process, in short. So, what about quality? There are some layers to quality. In an industrial system or software project, of course, you're going to have some stakeholders, many of them actually. The management, quality, project management, development, test, clients, and even more. So each one of these stakeholders has specific needs and expectations in terms of quality. Then you have your tool ecosystems, requirement management, design, code, test, etc. All of these tools are going to produce data which is going to be relevant to assess the quality. And then, of course, the project is living along a cycle, and this production cycle has milestones, and for each one of the milestones you're going to have some expectations also in terms of quality. So all of this combined means that to reach quality you have to take all of this into account. So it's really a data intensive and complex operation here. So a solution to monitor the data has to be both efficient, because there's a lot of data to handle here, and cost effective. So what about quality and continuous quality? Well, quality, to start, it is not an act, it is a habit. What it means here is that to properly monitor quality, you have to continuously evaluate it. So the benefit from a continuous quality evaluation is that you're going to be able to meet your quality objectives, because once everybody agrees on how and what to evaluate in terms of quality, well, individual actors, stakeholders will know what to look for, and the side effect of quality drifting can be avoided. Then it is easier to comply with standards. Many standards first of all ask for a continuous evaluation of quality, and if the quality is evaluated, well, it's easier to answer the different requirements of such standards. And then you're going to be able to improve your maturity, and this will happen at several levels: product, project, and process. We'll get back to that. So how to address quality? Well, the benefits first. What we aim for is to have a good corporate image, customer satisfaction, and business revenue. So all of these benefits will depend on your quality strategy. What's the first strategy? No strategy. If you do nothing at all, maybe you will have you are getting lucky and your project does good. So good corporate image, customer satisfaction, and business revenue. But if you do nothing to maintain this, there is a good risk that these benefits will decrease in time. Then there is a one-shot effort strategy. For example, there is an audit coming up. All the teams are mobilized to work on quality. You will reach your objective, but it will cost you. And then there is a continuous effort, and this is maybe costly at the beginning, because you have to train your teams and they have to understand what to do, how to do quality. But once this is done, well, the benefits are really clear, and not only are the stakeholders going to know what they have to do and produce, but also the quality level will raise when the process is in place. So continuous quality has long-lasting benefits. What about what you deliver? Well, if you have to deliver a system which is composed of hardware, software, configuration files, etc., well, if you do not have any quality strategy, you do not know what you really deliver. Is it good or not? I don't know. Well, not good, of course. in the one-shot strategy aspect, you're going to reach the desired quality as we saw before, but if you do nothing, well, maybe the quality will decrease because you do not continue to work as you did in the one-shot strategy. The continuous control, once all the teams, as I said before, are used to do and confident in using the quality monitoring tool, well, the quality will be met as the different versions of the product are released. And there is a bonus to that continuous control. If you regularly verify, analyze your process, how your tools are being used, well, there is a possibility to raise even more the quality being produced. So how to achieve quality? Let's talk about these levels once again, product, project, and the process. At the product level, the quality means checking your design elements, tracking your requirements, are they properly defined, refined, checking the tests, and also analyzing the source code. There are many source code checkers out there, so that's what you're going to look for. In terms of project quality, we are more focused on time and cost. So is my project going to reach the objectives in time? Are the milestones going to be passed healthily? So this is this kind of concerns. At process level, the quality is more a question of practice. Are my development tools development teams going to apply the company development practices? Are the methods going to be properly optimized? Are my tools being used properly? All of these questions are going to be in the process quality area. So all of these, and this is really just a small example, there are many more in each category. All of these are used to produce indicators. So an indicator is a way to compute quality, an aspect of quality, and it has to be shared by all stakeholders, so everybody agrees on what it means and also agrees on how it is computed. And once you agree on these two things, you will be able to generate them automatically, because obviously with all these indicators, you are not going to ask the stakeholders to compute them. Of course, this has to be done automatically. And software production is really a good fit for this kind of approach, because there are many tools producing data, and indicators can be generated using this approach. And then indicators is really the cornerstone of what we're going to do. They're going to be used in the quality monitoring we're going to describe now. So if we focus on software quality production, in a classic DevOps phase, you are going to have some checks which come from requirement management, design, source code, test, validation. But we are going to introduce a step called quality gate. So in short, quality gate is a checkpoint or an alert. What you want a quality gate to be is to be flexible, because obviously not all projects have all these phases. Some are just beginning, some are at the end, etc. So you must be able to pick and choose what your quality gate is going to verify. It has to be replicable. If you spend the time defining a quality gate, it has to be relevant for a project, but it is also relevant for other projects. So it has to be applicable, replicable. And then, since we are in the DevOps environment here, obviously a quality gate has to be automated, fully automated, with no manual operation whatsoever. Some examples of quality gate. There are several families of quality gates. There is a check family. In this example, what we need to know if my global code coverage above 50% or not. This is really kind of a green light, red light test here. And for that, we're going to check that the project coverage is the appropriate level. Then there is an encourage family kind of a quality gate. Here, for example, we're going to check that for the code I am just introducing, there are no violations, no rule violations. This is done using the new technical debt indicator, and using this it's quite easy to make sure that no new rules are being violated on the new code. There is an inspection type of a quality gate. With this type, what we do, for example here, we want to make sure that the coverage is compliant with not only different coverage targets, okay, statement, branch, MCDC, but also depend on the level, okay, the SIL here, ABCD, meaning that it's much more precise than the first check objective here. Here we're going to inspect the project and make sure that each component, subcomponent is compliant with this kind of table. And then there is a monitor kind of quality gate. This is a more top level quality gate. And the example here is if you have requirements, code and tests in your project, you are going to make sure that the stability of this object is compliant with the lifecycle. What we do here is we follow the traceability links between these objects and, for example, verify that if a requirement which is linked to test changed, we want to make sure that the tests are also updated. So let's take a look at Squore in all this story. Squore here in this continuous integration pipeline. First of all, we have some tools, source code analysis here, unit testing, integration testing. All of this is going to be provided to Squore. Squore is going to do the quality evaluation. That's the very first step here. If there are more data coming from requirements, tickets, or other tools, they can be added to the evaluation as well, so it's more precise. Squore is going to do a second thing, which is to check the quality gate or quality gates. So this is really important because this is the moment where we know what the quality evaluation is on the project, and so we know also our expectations, and so we know if you have to stop or continue. If we continue, Squore is going to be also able to generate some quality report based on all the indicators evaluated before. So to summarize, we have a data production phase here, which is going to feed Squore for its evaluation, first thing, for the quality gate, second, and for the report generation. And these are the three steps the three aspects we're going to see in the demo now. Evaluation, quality gate, and report. And just to put some names on what we're going to see, in the Jenkins pipeline we're going to see now, there is a C code project on which QAC is run, so MISRA checking. MISRA rules checking, Vectorcast is used for unit testing, and Squore Analyzer is used for static code analysis. Using all this data, we're going to do some rating on the project, and then some highlights to do the quality gates we talked about before, and then report generation. So switching now to Jenkins, here is a Jenkins project where the static code analysis QAC has been run, then Vectorcast and Squore, and the quality gate failed. So what happened? If we go into Squore now, okay, this is Squore. So Squore is has this navigation pane here where you have the project or the manager with its versions and the breakdown of the project here, okay, file, function, tests here coming from Vectorcast, and at the bottom here you're going to see some indicators which are used to rate the project. So on the dashboard here you have a view of the different functions with their coverage indicators, etc. And what we are interested in here is the highlight. If we take a look at this version here, which is the version where Jenkins failed, we can see that there are two elements which have been detected. These elements are outside the bounds of the quality gate. And if we go to the next version, well, the quality gate is empty. And what it means in Jenkins, if I go to the last version here, this time you can see all the stages have passed successfully. The quality gate passed, which can lead to the packaging delivery and report generation with Squore. And if we take a look at the report generated, in this case it's an Excel file which is generated in a few seconds. It will contain some overview of static analysis results, of coverage results as well. This is coming from Vectorcast. And then Squore is going to give you more insight on the technical depth of the different functions of the source code, also his compliance results, and also the coverage. This is also Vectorcast for each function. And the findings here are all, since we have been using QAC, these are all the findings found by QAC. So what we have seen here is Squore in action, meaning that it's a three-step operation. The first one is to get all the data. In our case is QAC, Vectorcast, static code analysis, to structure all of this data so that it can be rated. That's the second phase. So we apply a rating model to compute all these indicators, quality indicators, and once we have this rating on all the data, well, it's time to do some monitoring. So we can do some analysis, raise some alerts, that's the quality gate you were looking at before, and generate some reports if needed. And all of this is fully integrated in a continuous integration. You noticed that I didn't mention any specific industry. That's because Squore can address actually any industry, automotive, aerospace, IT, energy, etc. And also Squore is not linked to a specific process, so several processes can benefit from Squore. And so the highlight is the highlight of this presentation. That's what we were looking at today in Squore. A highlight is really a way to find outliers in Squore, to find elements that are triggered, okay, and this is all configurable. So we have an editor in Squore, and once you have edited your highlight, well, you have a quality gate which you can introduce in your continuous integration. As a conclusion, Squore in a continuous integration brings benefits for quality at two levels. On a daily basis, well, Squore does all the heavy lifting, meaning all the quality indicators, computations, getting the data from the tools, all of this, Squore is going to take that in charge. And then it's going to allow the users to be focused on what is relevant for them, so shared responsibility here. And of course, what happens is that day by day you will know how your quality evolves. In the long run, Squore is going to have some benefits as well, because the cost is going to quickly be smoothed out as soon as Squore is integrated in the continuous quality process. And speaking in process, the quality will be part of the process. It will be part of the process because it will be regularly computed, but also regularly checked and regularly reported. So these are really strong benefits in the long run. And as we saw before, the maturity is going to also benefit from Squore, because as the teams know what's wrong and how to solve it, it will become integrated in the way they work, in the way they approach the project. Thank you for your attention. We have explored together the topic of deploying continuous quality for software and system projects with Squore. There are many benefits to continuous quality. You are quickly alerted of quality deviations, and by reacting in time, you are getting better at anticipation. And Squore is here to help you all the way, by automating data capture, computing quality indicators, raising alerts on quality gates, and generating quality reports. I'm looking forward to your questions. See you in the Q&A session.